Hey everybody, welcome to my YouTube channel. Today is day 22 problem, which is count number of nice subarrays. Given an array of integers, numbers, and an integer k, a continuous subarray is defined as nice if there are k odd numbers on it. Return the number of nice subarrays. For example, we can see in the given numbers 1 1 2 2 1 1 1 and k is equal to 3, we can have maximum 2 subarrays. So the only two possible configuration is this one and this one. And also in case of this one, we don't have any odd number, so but we are requested to make a subarray with at least one odd number. So in this case the answer is 0. So based on the problem statement, one thing that comes into our mind is one can notice that we don't need really, you just need two categories, odd numbers and even numbers. So in that case we can use binary. So the odd numbers will be represented by 1 and the even numbers by 0. And then we can sum up and check if the number of odd numbers in the subarray we just created is equal to 3 or is equal to k. In this example I was saying 3 because of this example, equal to k. Then we can increment the subarrays. So for that we can use prefix sum with the help of a hash map function. So let's take this example. Let's consider this example. We have this subarrays. Sorry, we have these arrays, and then we have k value equal to 3. As I said before, let's make all of them even numbers. We make them 1 or 0, and for the odd numbers we make them 1. So we can use modulo 2 for that purpose. So 1 is 1, 1 is 1, 2 is 2, modulus 2 is 0, so on. So let's have this prefix function that will be a hash map. So the keys will be the current sum. So initially 0, and then we just iterate through the numbers and we'll add them modulus 2 to this value, to current value. So initially we are here, the initial value of it is 0, so we have seen it, the value will be 1. We have seen it 1 times, but then it will be 1 plus this equal to 1. So we check now if current sum minus k is in the prefix sum. Current sum is 1, k is 3. Let me write just the value of k. I've seen k is 3 in this example. Since k is 3, so 1 minus 3 is minus 2, so nothing. It's not in the prefix sum. So we move on. Next. So it will be 1 plus 1. So current sum plus 1 is 2. 2 minus 3 is minus 1, which is not in the prefix sum. Hash map function. Then we have to put 1 first. I jumped this. Every time we have to put the current sum in the prefix sum, so it's 1, and the value will be 1. So we move on, we'll add 1, so it will be 2 because of this one. 1 plus 1 is 2, so 2 minus 3 is -1, which is not here, the prefix sum. Then we'll add this. First of all, you'll add the 2. So the current key, you'll add it. So it's 1. Then we'll move on. 0. So 0 plus 2 is 2. The value doesn't change. We check 2 minus 3 is -1, which is not in the prefix sum keys. So we'll add again. Next time we'll update. So the value of 2 is 1, but since we have seen it the second time, we'll update. The value will be 2. Then we'll move on. Here, the value will be 3. 2 plus 1, 3. 3 minus. So now this time 3 minus 3, k is 3, is 0. And we have 0 here. So this condition holds. Now we have to update subarrays, this variable. Now this variable will be from 0, initially 0, then it will be updated to 1. Because the value of the key is 0, but the value corresponding to that sum is 1. So we have seen it 1 time. Now we move on. We update 3, put it in a hash map. Then the value, we haven't seen it yet, so it will be 1. This is the first time I've seen it. So the current sum value is 3. So 3, we move here. We move here. 3 plus 1 is 4. So 4 minus 3 is 1. 1 is here. So it's in the prefix. Now we update the value of, let me just, so the actual value of current sum is 4. For this it was 1. Now to that 1 we will add the value of corresponding to 4 minus 3, which is 1. This value is 1. So we'll add that value here. 1 plus 1 equal to 2. So the current value is 2. We put 4 here and then put 1. Now the loop breaks because we will not loop anymore. So the answer is 2. In this approach, the complexity will be O of n, the time complexity. Since you are using a map to store the summation and how many times you have seen them, the space complexity will also be n in the worst case scenario. Space complexity. This is time. However, there another approach where you can use sliding window. Since you have used this method yesterday to solve the previous day's problem, I decided to not use it today for solving this problem. But this solution is more efficient because the time complexity will still be O of n, but the space complexity will be O of 1. So it will be constant. And how the approach works is we'll consider a windows where you have, let's say, start, and let's just say, and then you have end here. So you will just sum up. Since the main idea is same, in that case you will also modify the values to be 0 and 1 based on even is odd or even. If it's even, it's 0. If it's odd, it's 1. And then we'll sum up. And if that value of a window is equal to k, we'll increment the array, sub-arrays. So at the end, we'll just return it. So, but today, let's use prefix sum. Let's dive into the coding part now. I'll be using Python 3. Hopefully, the writing is and that's the maximum I can have. So let's dive into it. First of all, let's define the values. The sum will be 0, current sum. The sub-arrays is 0, and the prefix sum is a hash map with equal to 1. So first time, then we loop through, iterate through the values, range of so the current sum will be plus numbers I modulus 2. Then we have to check if the current sum minus k is in prefix sum. Then we update the sub-arrays. Sub-arrays b plus prefix sum of current sum minus k. Now we'll update the the prefix sum will add the current sum. So it will be equal to, you will get current sum 0. If it's the first time I've seen the element, it will make it 0, and we'll add plus 1 to make it 1. If it's a old value, you just return the value assigned to that. But if it's the first time we're adding a value to the hash function, to initialize it to 0 and add it to 1 to it. So that's pretty much it. You just have to return sub-arrays. Let's check. Yeah, I passed the test. Now let's submit it. Yeah, as I said before, consistency is the key. I'll be consistent, by God willing. So that's pretty much it. Yeah, you can see it's O for N for space complexity. Thank you so much, guys. Please subscribe, share, comment, and thank you for the suggestions from the people who give their time to watch the videos. And this really it today. So see you tomorrow.